Thank you for your patience.
Happy to join.
Can you hear me?
Are you okay? Yes.
Oh, cool, cool. And welcome to a live feed to Denmark. We've been going. That's James in the back. You can see him. We've been going on for 6 hours now. We've been talking about empowerment to the people. We have had Jens Duvik and Thomas Diaz talking to us, giving some nice speeches. So, so now we are just hoping that you can give us a small insight from your point of view on.
Sure.
Because it's also a very special day for us, because it's the first time that we gathered all the Fab Labs and makerspaces in Denmark. So we're trying to, so on one hand we're trying to inspire to be everybody who's not a lab or makerspace to become a maker, and on the other hand we are trying to gather our forces within the spaces and labs. So how can we combine the efforts? So that's the two main themes for today.
Okay. Tell me again, where are you meeting right now? Where are you located?
Denmark, Odense. Odense, Denmark.
How do you spell Odense?
O-D-E.
Oh, N-S-E. Got it.
Thank you.
Got it. Okay. Good. Well, delighted to see this group gathered. Fab Labs were an accident. There are about 200 right now, and they're doubling about every year and a half. So there's about 200 coming. Our project was to set up just one of them. And so this doubling has been, we didn't plan that. And I wanted to talk a bit about why that's happening and where it's heading. So the Fab Labs were outreach from research we were doing on the idea of digital fabrication. And that has a casual meaning, which is just a computer controlling a machine, but it has a much deeper meaning. And so if you're interested in the research behind Fab Labs, last spring we ran a meeting with the White House Office of Science, Technology Policy. If you go to the CBA site at MIT, you'll see the presentations and videos. And so to understand the distinction, in 1952, MIT made the first computer-controlled milling machine. First time a computer was connected to a machine to make things. And since then, there are about 20 ways computers control machines to make things. And so it went from milling to cutting to burning, and now additive rather than subtractive. But 3D printing is still basically the same process. A computer moves a head around that deposits the material. Technically, there's a much deeper distinction between analog and digital. So phone calls were analog. I'm talking to you now through the internet. The internet represents information with codes that let you detect errors. I'm talking to you through a computer. Computers were analog, now they're digital. And again, using digital codes lets you detect and correct errors. And so the real research on digital fabrication isn't digitizing the design in the computer, it's actually digitizing the materials themselves. We're studying how to put codes and programs into materials. And so if you think about Lego bricks, you don't need a ruler to place Lego bricks because geometry comes from the parts. A Lego tower is more accurate than the child because you can detect and correct errors. And when you're done, you don't put Lego in the trash, you disassemble and reuse it. And those are all properties of digital systems. And so the research on digital fabrication is on length scales from molecules to integrated circuits to airplanes to buildings, studying how to actually put codes into the construction of materials to digitize fabrication. So the casual meaning is I send you a design and you can make it. The deep meaning is the design actually becomes the object itself. Now, we're getting there in stages. The first stage is computers controlling machines. And that's the Fab Lab era. The second stage is machines making machines. So the second generation of Fab Labs, you won't buy the machines, you'll go to a Fab Lab to make the machines. The third stage is instead of printing or cutting, you'll assemble micro parts. And the final stage is there's no machines. The materials themselves are programmable. And that's about 20 years of research. But to understand where we are today, there's a very close historical parallel. There are mainframe computers, then mini computers, then hobbyist computers, then PCs. Mini computers cost about $100,000 and filled the room. But that's when internet, email, video games, word processing, all that stuff happened. Because a group could use it rather than a whole corporation. And so now to line it up, the 1952 milling machine is like a mainframe. Fab Labs today are just like the mini computers. The machines that make machines are like the hobbyist computers. And the microassemblers are like the personal computers, the Star Trek replicator. And so the internet wasn't invented after the iPhone. It was invented long before it, and that's what you're doing today. All the tools in a Fab Lab are going to get merged into one process, but that's many years of research. But you don't have to wait for the research to be done to invent the internet. You can use, today you can do what you will be able to do in the future. With a PDP, you could do what's possible on a PC now. It costs more, but was bigger, but you could do all the applications. And so you're exactly at the historical stage we are that's analogous to inventing the internet. So technically, we ran a meeting a few months ago in Moscow on Fab Labs 1.5. And the idea of that is not a Fab Lab making a complete Fab Lab, but a Fab Lab making some of the machines in the Fab Lab, halfway through the transition. And in support of that, we've been doing a lot of work on not any one machine, but on rapid prototyping of rapid prototyping machines. So technologies for machine building. So it's as easy to make a machine as a project with a machine. And so in the Machines That Make project, we've been developing motion control systems and virtual machine logic and real-time networks and structural systems. And in the CoCompi project, we've been developing geometry engines for CAD and CAM and task planning and user interfaces. And so a complete end-to-end workflow for CAD, CAM, and machine control to build machines to bring all those components together. Now, as that technology has been developing, a very useful project that's been growing is the Fab Academy. And the idea of that is we had bright kids coming to the lab, learning skills way ahead of their local schools, and then falling off an educational cliff. And so rather than going far away, or just having online classes, the way the Fab Academy works is students have peers in work groups with machines and a mentor in the Fab Lab. Then we link them by online video and content sharing. And so in computing terms, MIT is like a mainframe. You go there for processing. Massive online classes are like time sharing. You're a terminal connected to the mainframe. The Fab Academy is like an internet for education. It's a distributed educational network using the whole Fab Lab network as a campus. And that's been working really well for a couple things. One is to propagate best practices. Each year a group assembles and goes through all of the workflows and processes and updates them. So driving best practices in the network. And one of the really useful things it's been doing is a bootstrapping of training trainers, training the gurus. There's great demand with the rapid growth of these technologies for gurus who are masters of the skill. So the students who go through the Fab Academy, we have a number of both new fab sites and companies looking for people with those skills. And this has been a really good engine to train them. So in turn to keep up with this growth, we've had to spin off a Fab Foundation. And the idea of the Fab Foundation is it's a global wrapper of regional programs. And so there's a number of strong regional programs, like in the Netherlands or Spain, or like what you're doing. And then the Fab foundation connects them globally. And what it's doing is a lot of different things that are above the scale of any one lab. So each lab doesn't separately need to negotiate a deal for a laser cutter. We can do those as a group. There are a number of donors that can do government agencies and philanthropic donors and companies doing corporate social responsibility that can help invest in the lab network, but they can't work on the labs one-on-one. They need an entity they can work with. Functions like curating the list of labs or providing regional supply chains for the specialized materials are all functions that are bigger than any one lab can do. They're functions of the network. So that's what this growing Fab Foundation is providing and connecting across it. One of the most interesting developing trends in the US for that is there's legislation in the US Congress to make the Fab Lab network a national laboratory, to make it a national lab of connected local labs. They're still local labs as you know them, but they also serve the functions that we used to look to remote national labs to provide. So that's some of the organizational growth. And if you're interested and haven't yet come, once a year there's meetings of all of the Fab Labs, and it's cycled. It was in Japan and Yokohama last summer. The coming summer is going to be in Barcelona. This is Fab 10. And we use video, we use all kinds of tools, but something happens when everybody comes together that you can't match with all of the remote tools. It's a wonderful gathering. This one is fun because Vicente Gallard, who started the Fab Lab in Barcelona, Tomas's colleague, is now the city architect, the planner for Barcelona. And Tony, his collaborator, is the deputy mayor. And the connection is there's 50% youth unemployment in Barcelona, but a great design sense. But the economy buys products that come on ships made far away. And so they're filling the city with digital fabrication tools as part of the civic infrastructure. You expect the city to provide power and sewage. Now the idea is the city provides tools for fabrication as part of the infrastructure of the city. So you're globally connected for knowledge, but can locally produce what you consume. And a fun project we're going to do there is build a house as part of the Fab Lab meeting, where parts will be designed at labs all around the world. People will arrive with data, and then using the city, the labs across the city, it'll get built, and then the plan is shared if anybody else wants to make one. And so that's coming up this summer in Barcelona. In looking at this growth, I'd say the thing that lags the most, but is evolving in interesting ways, is the business platform. So most labs struggle for funding. What we found is in the lab, you can develop something and sell it, and that's the obvious way to make money. But so far, the successful business models haven't been that. They've been closer to services. So Blair in Detroit sells the lab as a social service for at-risk youth, where the impact is the benefit on the kids for coming to the lab. And a good part of the funding for the Barcelona lab comes from the educational programs they run with it. And there's a project that started at a lab in Afghanistan that's running in Kenya that's providing citywide internet access as a service produced out of the lab. So there are a number of interesting business models for services. But I'd say the one thing that hasn't yet developed that I'd like to see develop is distributed platforms for buying and selling. You could design something locally and produce it anywhere in the world, and stuff designed anywhere in the world can be produced locally. What hasn't yet developed is platforms to intermediate that distributed buying and selling across the network. We're already using the lab network as an educational campus. We could also use it as a production facility, and I think that's a nice challenge going ahead. So, stepping back now, all labs that fabricate aren't Fab Labs. The idea of the Fab Lab network is it shares an evolving set of capabilities that tracks the research roadmap that lets people and projects be shared in the network. So anybody from any lab can work in any other lab, and really functions as a growing network. And as it matures, as we develop, we didn't set out to build organizations, but as the Fab Academy and Fab Foundation and these business platforms grow, I'm coming to appreciate that I thought the hard part was the technology. That's progressing nicely. The invention, the hard part, is analogous to inventing the internet. If anybody can make anything, how do you live, work, and play? What is the structure for that? And we found the incumbent organizations in each of these areas just don't fit. And we really had to invent our own organization. And so beyond just meeting today, what you're part of is a much bigger project, which is inventing what are the new organizational structures for this world, where instead of a factory being a remote place and a school being a remote place, all of those functions merge in a sort of in these kind of community digital fabrication facilities. And so Fab Labs at heart are a grand experiment in inventing how do you live, work, and play, and building this organizational capacity to keep up with this technology roadmap. So that's the state of Fab Labs. Delighted to see you joining, and I'll be happy to take questions and discuss. Thank you.
Thank you. I have a question. Going back to what you said in the very beginning of our presentation, you only wanted to do one Fab Lab. When do you recognize that this was going apeshit?
Yeah, so let's see. Fab Lab 0 was in rural India. I was doing a collaboration with India's government, and I was working with a really saintly person, SS Kalbag in Vidyanashram in western Maharashtra. And he was the one who impressed on me. I thought we would help bring solutions to problems. And he was the one who really impressed on me. They didn't need solutions, they needed tools to make solutions. And so that was the first site, remote site, we brought some machines in the field. Then Fab Lab 1 happened, like around 2001 or 2, about 10 years ago. And the way that happened was that we got a lot of money from the National Science Foundation to buy machines to do the research. And then Congress passed a law where the NSF had to measure social impact. And so NSF didn't know how to do it, so they turned to the big grants and said, measure social impact. And we didn't know how to do that, but we thought the machines were cool. So rather than make a website, we went to a community center in Boston, and it's a wonderful site. Mel King was a famous community activist who really led bringing technology into the inner city. And so we set up a Fab Lab with him, and it naturally fit his evolution. And so that was Fab Lab 1. And we thought we were done, but then what happened was there's a strong Ghanaian community in Boston. And so when they saw what we were doing, they wanted a Fab Lab in Ghana. So that led to doing one in Sakandi Takoradi. Then there's a strong connection between Ghana and South Africa. And so that led to a collaboration that made a first lab in Pretoria, then Soshangovi, then Bloemfontein, and then all over South Africa. Then there was a strong connection to India from South Africa, and that led to some labs in India. And then one of those connections led to doing one above the Arctic Circle at the top of Norway. And so we got up to about 10 labs. And that's when I realized we were beginning to, that this was beginning to go crazy. That, at this point today, every day I get a message, I want to create a Fab Lab. It's about once a day. And every week or so, I get these really difficult messages where somebody says, I'm canceling my life, where do I report? And so a lot of our effort then has been, so once we got up to about 10 labs, it was clear this was going to explode. And the annual meeting, we only plan to do that once or twice, but it's now become this growing annual ritual. Yes, last year we had 1,000 people in a big hall in Yokohama. our initial attempts to build the organizations to keep up with this failed because this is so distributed. We tried, this is the third time making the Fab Foundation. The first 2 times failed because we tried to make an organization. The third time succeeded because it's a global wrapper for the local effort. And so each of these steps in the organization building, the art is to get right how to make it scalable and distributed, but also leverage the strength of the network. A related comment to that is, I of course love the maker movement and hacker spaces, but on the other hand, in the maker movement, in Maker Faire, things like that, there's also a lot of really bad engineering of people who don't have access to mentorship to understand where they're doing something that's been done before and there's better ways to do it. And I think one of the strengths of the Fab Lab network is being able to do simple things quickly, but providing mentorship to go from easy to hard things in the network. But yeah, so about, I'd say, looping back then, about Lab 10 is when I realized this was bigger than just an outreach project.
Thank you. Thank you. Any other questions? No questions? Well, then there's nothing more to say.
Let me just give it a minute. I'm interested in hearing from you, not just me talking. Let's give it a minute for questions and comments.
All right, I have a quick question. I basically wanted a Fab Lab all my life. And a little more than a year ago, I went to see an organization that helps startups and talk to them about who they could connect me with. And then I ended up the next day opening a newspaper and saw, hey, Fab Lab is coming to Odense. And I immediately applied for a job here, and I luckily got it. And I've been here a year now, and my experience is that I don't teach and instruct in the machines as much as I expected to. I use inspiration mostly. I'm trying to inspire people that come to the Fab Lab instead of teaching them how to do it. And my experience is that every time I need to inspire people to be interested instead. How can you come with any kind of input on that experience?
Sure. Yeah, so let me position your experience in 2 axes. There's things you can do in the Fab Lab that take a day, a week, a month, a year, a decade. It's great you can come into the lab in an afternoon and make a keychain on a laser cutter. On the other hand, you don't want to get stuck making keychains. And so it's better to think about this, your question not either or, but as a flow. Bringing people in, inspiring them, empowering them, exposing them is great to start with light, quick, fast things. And then it's nice to have a pathway where in steps you can go deeper and deeper. So the way we do the Fab Academy, there's 1-week topical units that you can do separately on each of the skills, and then you assemble them into projects, and then from those projects, there are steps you can do more deeply. And so think about it as careers. Some of the things you can do in the lab need advanced degrees, some a kid can do on their first time, and there's a lot of interesting steps in between. Filling that kind of whole evolutionary path is what interests me, so you can come in, get inspired, and then progress to deeper and deeper knowledge. And part of the point of the Fab Academy is developing the content to do it, to go from easy to hard, is too much work for any one lab to do. We all want to work together as a network to develop that. Likewise, there's another axis. In powers of 10 and dollars, my facility at MIT is about $10 million. Think of it as 10 $1 million machines that lets us do molecular nanoassembly and make carbon fiber airplanes. One level down, we have a workshop that's about $1 million and $100,000 machines that includes water jet cutters and high-speed machining. A Fab Lab, think of it as $10,000 machines, $100,000. And that lets you make almost anything. In particular, it has all the machines you need to make the machines. A level down from that is for about $10,000 with 10 $1,000 machines, you can do a project. You can add a 3D printer and a milling machine to do projects. It's not yet enough to make the machines, but you can make projects with them. And finally, for $1,000, you can get one machine that can make a part. And so a common misconception is to say, oh, Fab Labs are too expensive, I can get a $1,000 3D printer. If you take the analogy with libraries, I have books. Okay, the network dropped out. I have books behind me on a shelf. I have a town library that has more books. I have a library at MIT that has more books, and we have the Library of Congress that has more books. MIT's library isn't obsolete because I have some books at home. They're different scales. So in the same sense, a $1,000 machine sits on a desktop and lets you make a part. A few $1,000 machines lets you do a project. A Fab Lab is like the scale of a town library. It's not made obsolete because you have a machine at home. It's a suite of machines that lets you create machines. And then, in fact, one of my interests is there's tools you can't afford in a Fab Lab, but you need access to do even harder projects. And so I'm very interested in creating a network of effectively super Fab Labs that can do things like microtomography, CT scanning, and things that cost as much as the Fab Lab themselves. So it's better to think about your question not as a point, but as kind of flows and axes and careers of how people flow through the network.
All right, thank you.
Anyone else?
I have one more time.
You go ahead, Mass. You go ahead.
All right. We've been talking today a little bit about Fab Labs as public libraries and how that may threaten other companies as in, you know, being competitive to other professional companies, and how is your view on that?
Sure. So what's really surprising is if you take the history of mainframe computers and then personal computers. Ken Olson, the head of digital equipment, which made the mini computers, the PDPs that were used to invent the internet, famously said nobody needs a computer at home. And you know, DEC is bankrupt. The mainframe computer companies, almost all of them considered personal computers toys until they destroyed their business. The only one that survived was IBM, and it essentially completely changed its business. So our experience has been companies in really difficult, challenging technical industries, like we have a great collaboration with Airbus. They get Fab Labs because what they do is hard. Existing companies, in particular mid-sized companies, don't get Fab Labs because all they want to do is use the machines to do exactly what they're doing. We've had much more luck in creating new businesses that work fundamentally differently than changing existing ones. And so to your question, the companies that should be scared aren't, because they consider this a toy. But the inverse of that is trying to have an economic impact by working with local companies generally is frustrating. It's a better use of your time to create entirely new businesses. And by the time the companies figure out they should have been scared, it'll be too late and the economy will have changed out from underneath them.
All right, thanks.
Any more, Mass?
I guess not for the moment.
Oh, okay.
I have to think anyways if that more.
Anyone else? No? Then I'll just say thank you very much for your time.
Okay. Great to see you gathering. Good luck, and look forward to visiting in the future.
Cool. Have a nice day. Thank you.
Thank you.